Hello, and today what we're going to do is we're going to talk about section 9.2. All right, previously in the day before we did section 9.1 when we tested for sigma being known. We're comparing two averages and we know our population standard deviation. Today is when we're going to work and our sigma is unknown. Okay, we don't know our population standard deviation. I put a couple notes up top. In section 8.2, that buddied up with section 9.1. All right, those are the two examples where we're working on averages or means, okay, and we do know sigma. So we use norm CDF for our p-values. So same exact concept, last chapter in section 8.3 pairs up with this chapter, section 9.2. We don't know sigma, which means we need to use TCDF, okay? Otherwise, it is the same process that we just practiced in section 9.1. Your formula is virtually the same, okay? If you note back here, the numerator looks the same, except it's got sigma squared and sigma squared. Well, now we have S squared and S squared. This is still for your first sample. This is still for your second sample. One of the keys to remember that you want to make a note about is that if your sample sizes aren't the same, right? If it's not like 2 samples of 30 students is selected, and you've got maybe 30 students in one sample and 27 students in the other sample, that when you do your p-value with your t-chart or your TCDF, your degrees of freedom are going to be the smaller degrees of freedom. So if you have 2 sample sizes that aren't the same, pick the smaller sample size and do the degrees of freedom for that sample size. All right? But other than that, this is going to feel very familiar. So if we look at number 1, the local branch of the IRS spent an average of 21 minutes helping each of 10 people prepare their tax returns. The standard deviation was 6.6 minutes for the 21 minutes that was helping the average of the 10 people, okay? So this would be a sample standard deviation. Note it doesn't say population here. Then there's also a volunteer tax preparer, and they spent an average of 27 minutes helping 14 people prepare their taxes, and the standard deviation was 4.3 minutes. At alpha equals 0.01, is there a difference in the average time spent by the two services? So first thing you want to do is organize all your information. So I did that off to the side. My first category is the IRS. My second category is the volunteer tax preparer. I used S because we were not told specifically that they were population standard deviations, right? It was 10 people, had a mean of 21 minutes and a standard deviation of 6.6. So that's a sample mean, all right? Then you got to move over to your hypotheses. So if it's saying, is there a difference in the average time spent? Difference means equal, not equal, two-tailed test. So I have my IRS first, my volunteers second, right? So then you can jump on into your formula. It's x bar 1 minus x bar 2. And then it's standard deviation squared over n1 plus standard deviation squared over n2, right? So this is all the IRS and this is all the volunteers. The order in which you subtract has to match which one you listed as the first one and which one you listed as the second. Make sure you can type this in and that your answer matches mine, negative 2.52. Now, if it's equal, not equal, that means it's a two-tailed test. So when you set that up, okay, this is where you've got to be careful. Your degrees of freedom, down here, sorry, we've got a sample size of 10 and a sample size of 14. So when you're figuring out your degrees of freedom, you're going to go with the smaller sample size, 10, and then subtract 1 to get 9, okay, which is why I use that here. So I'm going TCDF is negative infinity to negative 2.52. So lower bound, upper bound, degrees of freedom. That gives me 0.0164. I'm going to double that because it's a two-tailed test, and here's my p-value. Then I pop on up here. My p-value is greater than the alpha that was requested for this problem. This problem asked for alpha equals 0.01. Do not reject the null means that we can't conclude there is a difference in the mean times to prepare taxes. We can't conclude that they're not the same. All right, so if we take a look at number 2. And if you're feeling comfortable, you guys can just kind of like try them. I encourage you to try these on your own because this should feel really comfortable after yesterday. We're just making that small change of using TCDF instead of norm CDF for your p-value, just like we practiced over and over again last chapter. All right, so males and females alike from a general adult population volunteer an average of 4.2 hours per week. Random sample of 18 male college students and 20 female college students indicated these results concerning the amount of time spent. So here it actually already organized it for you in a table. All right, we want alpha equals 0.05. Is there sufficient evidence to conclude that males volunteer less than females? So go ahead, I encourage you. I hope you are practicing these on your own, okay? We've got males less than females. We've got our formula, okay? Males, females, it's a left-tailed test. Our smaller sample size was 18, which is why we have 17 degrees of freedom. Here's our p-value. We are not doubling our p-value because it's not a two-tailed test. Our p-value is greater than alpha, which means do not reject the null, which means we cannot conclude that males volunteer less than females. We don't have enough evidence to make that conclusion. All right. And then the last problem. Okay. The average size of a farm in Indiana County, Pennsylvania is 191 acres. The average size of a farm in Greene County, Pennsylvania is 199 acres. We want to assume that the data were obtained from 2 samples with standard deviations of 38 and 12 acres respectively, and samples of size 8 and 10 respectively. Can it be concluded at alpha equals 0.05 that the average size of the farms in the 2 counties is different? So yes, the averages are different, but are they far enough apart to conclude that they're definitely going to be different from each other? Right? Or was it just a fluke in the sample? So you jot down all your information. Okay, organize your thoughts. Indiana, here's our info. Greene County, here's our info. Different is equal, not equal. You're going to have your formula. Your smaller sample size is 8, so that's the one you want to use for your degrees of freedom. So we're going to have TCDF negative infinity and negative 0.57. We get this, double it, so 0.5864. Oops, I'm sorry, I'm off the screen. 0.5864 is your p-value, which is absolutely greater than alpha. So we're going to get do not reject the null, which means we don't have enough evidence or we cannot conclude that the average size of the farms are different. Okay. So I hope you took great notes today. I know this was kind of quick, but I'm hoping that it was okay that it was quick because at this point of the year, if you've genuinely and authentically been doing all your practice, we should be cruising. If not, I need you to come see me after school, right? We can set up a Google Meet if you're at home, or we can stay after school at lunch, like when you would be going home at noon, and we can get everything ironed out because as you can tell, hypothesis testing, significance testing, it is here to stay for the year. Good job today. Talk to you soon.